Okay, welcome back Physics 20s to our next lesson in Unit A, Chapter 1. This is 1.2 and today we're going to be talking about breaking and adding vectors. Okay, so in the last lesson we looked at the difference between a vector and a scalar. A vector has both magnitude and direction, so that means we need to consider the direction, and we're often going to put that in a diagram using vector arrows, like you can see these ones down here. And if we have multiple vectors, we're going to add them together to try and find the result. And if we have one at an angle, we're going to want to break that apart to see its components in the x and y direction. Let's take a look at that. So first it says they can be added together and they can be broken apart into their components. Let's start with adding them together. It's important to make sure they're the same unit. If you were looking at adding different velocities and one was in kilometers per hour and the other was in meters per second, that's not going to work. We need to make sure they're in the same unit. You also have to make sure they're the same term, like you wouldn't add a displacement to a velocity. They have to be measuring the same thing. The next part is when you're adding these vectors, it actually doesn't matter the order as long as they're added head to tail. So one after another, then the diagram should work. And your overall vector or resulting vector will be from the tail of the first to the head of the last. I would say second, but there could be more than just two. So let's take a look at that with these vectors down here. So I'm just going to make copies of them and put these together head to tail. So I'm going to make a copy and put that one down there, make a copy and put that one over there. You see that they've been added, this one to this one, head to tail. My resulting would be from the tail of the first to the head of the last and would be that yellow arrow. Now just to show that it doesn't matter the order, if you added them in the reverse order, so I'm going to use those remaining ones at the top now and put them together, see how they're added in the opposite order, it still gives us the same resulting vector overall. So don't worry about the order, just make sure it's head to tail. You draw your resulting vector as tail of the first to head of the last. Now I'll take a look at breaking vectors. This is when you have a vector that is at an angle. We looked at describing angles last lesson. If you need a reminder on how to describe them, take a look at that previous video. But now we're going to break it into its x and y components using sine, cosine, tan. All right, so the trigonometry also from the last lesson for knowing which trig ratio to use. This is often a first step in solving lots of different vector problems, so it's good to get practice at this and be confident in using sine, cosine, tan in this way. So we would want to look at the vertical component of this, finding that side, and the horizontal component, that side right there. And we want to figure out what the values of those two were. So let's apply this to an example. If a person drove 18 kilometers south and 23 kilometers west, what is the displacement? This is an example of adding vectors, and these aren't at angles at all. So I look at this vector, it's 18 kilometers south, then 23 west. I add them head to tail. Looking for the displacement, which is the result. So I'm going from the start of the first to the end of the last, which is my green arrow like that. Let's put the numbers on there, 23 kilometers and 18 kilometers. So I just need to use Pythagorean theorem to figure out the hypotenuse. So I take 23 squared plus 18 squared square root, and I get 29 kilometers. So similar to the examples from previous day. But since this is a displacement and it's a vector, we also need to take into account the angle. So looking at the top there where the person began, I need to find that angle and use my opposite and adjacent side. So the opposite's 23, the adjacent is 18. Again, we're looking at this angle right here to solve that, and I'm getting a value of 52 degrees. So we would have our final answer as 29 kilometers at 52 degrees. I also have to throw in there what of what. This is south, right? That directly down arrow, and this is the angle I'm looking at, and we are west of south. So I should put that in there as well. Sorry, the writing's a bit bad. West of south should be on the end of the answer. Now we're going to look at one that breaks a vector into its components. It says if an escalator moves at 1.2 meters per second at an angle of 40 degrees above the horizontal, how fast is it moving upwards? So we're looking for the component of how fast it's going up. We know it's going at an angle. We want to say how fast it's going up. So there's the motion at an angle, and I'm going to break it into its forwards and upwards components. But I put it in green there because that's the only one I'm worried about. So I know it's going at 1.2 meters per second on that angle, and I know the angle is 40 degrees. So I'm trying to find for the opposite, that's the green arrow there, and I know the hypotenuse, so I'm going to use sine. So sine 40 times my opposite over 1.2 is how I'd fill in that equation. I'm just going to times by that 1.2, and I get 0.77 meters per second for the velocity going upwards. So just finding that opposite side. Okay, so that skill of adding and breaking are basic concepts that apply to a lot of different types of questions. Now, the things that are going to make some harder is sometimes we might have to add and break vectors in the same question. So now we're going to take a look at one like that. Okay, so this one says that a car drives 25 kilometers at 20 degrees west of south, then 40 kilometers at 40 degrees south of east. What is the displacement of the car? Okay, so this is harder, and then we're adding two vectors and they are both angled. So this is a combination of the past two questions. I'm going to draw my arrows first, so that is 25 kilometers, 20 degrees west of south. And then this one is 40 kilometers, 40 degrees south of east. I'll just put in those angles to give you reference. Again, the first one, 20 degrees west of south, and the next one, 40 degrees south of east. Now, to find the resulting vector, which it's asking for with the displacement, I'm going to draw a line from the tail of the first to the head of the second, just like we did before. But the problem is this is not a right angled triangle. If I look at this angle right here, which I'm kind of highlighting in green, that's not 90 degrees, so we can't use trigonometry like we did before. Okay, so what do? When you have angled vectors, you break them into their components. This is a first step in so many questions in this course. So we're going to break it into their x and y components. Then we can look at those separately and make a better comparison between what's happening for each vector. So I'm going to draw a triangle here for the first one and draw a triangle there for the second. This is the breaking vectors part. So we're just going to use sine and cos to find the components. I'm going to put the components in here. That blue one is the opposite of the 20 degrees. That red one is the adjacent of the 40 degrees. Why I put these two ones first is it shows us what's happening in x. The blue arrow shows we're going a little bit to the west, and then the red one shows that we're going quite a bit to the east. So we can add those two vectors together to figure out overall what's the displacement in the x direction. So we'll do that, and then we're going to consider this blue line, which is the adjacent to the 20 degrees, showing how much that first vector went down. Then if we look at the opposite for the 40 degrees, that shows us how much the next vector went down. We'll add those two down arrows together and get a result for how far we went down. Okay, so let's get some numbers here. What I'm getting for going this direction, I'm going to call that negative because I have to make one side plus and one side minus. So I'm going to call this way negative, this way positive. You could call it east and west, but I'm going to call the west negative. And so that's 8.55 to the west or in the negative direction. And going down is 23.49. I'm going to call down positive. So those are the two components using sine and cos. Then looking at the next triangle, I get 25.71 going down, that's my opposite side, and 30.64 in the positive or the east direction. Okay, now I just have to put these components together. I'm going to put the x components together and the y components together. So let's see what that looks like. If I move this component up, I'm saying from where I start, I move 8.55 west. Now I'm going to put the next x direction, saying that I move 30.64 east. So then overall, that's my net vector. I'm just going to get rid of those other ones there of 22.09. So I'm just adding the x's to figure out my x displacement first. Now I'm going to do the same thing for the y's. I'm going to move this blue over and see those two added together is my displacement in y. So I take the 23.49 and the 25.71, draw that green arrow, which is 49.20. Now I have the overall displacement in x, the overall displacement in y, and I have a right angle triangle now. And at this point, we're not actually quite done because now we have to use those sides to find the hypotenuse and the angle. So if you find the hypotenuse with those two values squared using Pythagorean theorem, square root, I get 54 kilometers, And then if I look for this angle, using 49.2 as my opposite, 22.09 is my adjacent, so I'll use inverse tan. I get an angle of 66 degrees south of east. Okay, so thank you very much for watching this video. I hope it helps with your vector questions. Make sure you try the practice questions, and I will see you in the next video.